Guys, welcome back to Tutoring with Abdul. In today's session, we'll be talking about alternating current, AC current, or AC. Uh, Previously, we talked about series, parallel, and combination circuits. We kind of brush up this idea of what AC and DC is there. But in this lecture, we will go a little bit more into detail. So in this particular video, and I hope I can keep it to 20-minute each session, and this will be divided in two parts. Hopefully, we'll be covering what alternating current is, and what is the advantage of alternating current, and what is the alternating current waveforms look like, and how are they, and how many are there. So the AC waveforms. So it'll be square waveform, it'll be triangle waves, and there'll be sine wave, which is the most common one in the AC current. Now, once we talked about these things, then we will discuss what a sine wave values are, and then we will say, okay, so sine wave, like it's not, I didn't put it on this slide, but it has a peak values, RMS values, and average values. We will talk about these in detail in the upcoming slides. So then after that, we will have to review this session and see how that goes. So let's go ahead and we'll do some introduction about the AC or alternating current there. We talked about DC. Let's say let's differentiate between AC and DC there. DC is a current. DC or direct current is a current that goes only one direction, or it's a unidirection. It goes only one way. It cannot reverse itself. And DC, on the other hand, is a current that can go both directions. It can reverse its direction, or it can go forward. So most of the electric power that is produced in the world is alternating current. It is used to operate almost all electrical equipment that we use today. Starting from your house, just think anything like your fan, your TV, your microwave, your fridge, everything that is taking any electricity that will be AC powered. At house, we usually have 120 volts AC voltage there. We'll be talking, we will be just discussing what RMS value is there, by the way. But yes, just a big picture is that AC is alternating current that can go both direction. It forms sinusoidal waveforms or sine waves, and that cannot be provided by DC. So yeah, so that is a big kind of advantage of AC waveform. I mean AC current. So in this picture, in this slide, we will see advantage of AC over the DC is this guy is here Thomas Edison, and this is here Nikola Tesla. It's a This guy is American born, and this is a Serbian immigrant from overseas. So Thomas Edison is famous for his DC invention, and this guy Nikola Tesla is famous for his AC, and that's what we are. Because of his patent, we have a AC power in the whole world. So thank you, Nikola Tesla, and thank you also Thomas Edison, because without each other cannot be succeeded. So what is the advantage of AC over DC? So as you see, before we go into detail, that's the AC sign anywhere you see it, and that's especially on the meter. If you have a voltmeter or multimeter, that should be AC should be looking like that, and DC should be like that. All right, let's talk about the advantage of it now. So alternating current or AC current can be transformed while DC cannot be transformed. What does that mean? For DC current to be transformed, we need a lot of transformers to step it up, step it down. It's too many. It would cost a lot of money. It's almost impractical to do that, as per Nikola Tesla when he disagreed with Thomas Edison. But yes, just a short answer is alternating current can be transformed while DC cannot be transformed. Cannot be. There is no other alternative. Third one, second, transformer permits voltage to be step up or step down. So that is a definition of transformer. Can step it up or step it down. Step up is needed for transmission of the power, and step down is needed for when we have to use it in our devices, such as at home for microwave and TV. So everywhere you go, like if you have your house, right before your house, like where the power comes from, the grid should be having a transformer that will step down your voltage from 69,000 or 6900, whatever that voltage is. It will be slower, it will be lower voltage that will can satisfy the need of our house, which is 120 volts. Not mentioning the charging station, if anybody have it at home, like a Tesla charging station, chargers, anything that will require a little bit more of work. But other than that, that is the job of step down transformer, to step down the voltage so that we can use it at home. The normal or the common transmission voltage is 69,000 or 69 kilovolts, 138,000 or 138 kilovolts, and 345,000 volts. That's a high voltage to be that you will see like in the transmission lines there. So, but we don't need that much power there. We don't need that much voltage at our house. We just need a simply 120 and 200 to 240 somewhere in our fridge. 200. So that will be requiring a step down transformers. Now, we talked about the advantage of it. Advantage of high voltage transmission is that the less current is required to produce same amount of power. So that means the high voltage is like, let's say 69,000 volts. We are requiring to supply that voltage to the next setting. So we don't have to, the current should be very less to transfer the same amount of power, because if you have a higher voltage and you can bring your current down, you'll still get the same amount of power there. So that will save a lot of materials. Your materials will be saved, so there'll be no other issue. So everybody will be happy because you're getting the same power. Your wires will be not as big as they has to be, because if the current is, it depends on how much current you are transferring. If your current is low, you don't need a big of wires, cables, so you'll save a lot of extra cost there. So what is the idea and how did we get to AC over DC transmissions? Okay, so there's a I will link a video of a one minute video from someone else in the comment. I mean, in the comment section. If you guys are interested, you guys can go and check differences between Nikola Tesla and Thomas Edison's inventions and what they did. But here I will give you just a brief. Thomas Edison is an American inventor and the head of the Edison Company. He proposed that he can power the whole world, whole country with a low power DC. So that was his one assumption, that he can power the whole world with a low power DC. His reason was it could be safe for people to use it because it's not high voltage. Then also he said, like there was a 1904, there was a World Fair was going on, so his company bid to light a lamp for over $1 using a low voltage DC. So that is a 1904. He proposed that he can light up every lamp. For each lamp, he will charge a little over $1 using his low voltage DC power. While on the other hand, Nikola Tesla is an immigrant from Serbia who at that time worked with the Westinghouse company. Nikola Tesla, just to remind you guys, he did work for Thomas Edison, but they did not agree on something, so he left the job or he fired him. I don't know the history of that, but like it's a different stories from there. But yes, he at one time he did work with Thomas Edison's company. They had disagreement, and then he had to go work with Westinghouse company, because these two company was the main two electric company. They had they were in the business. One was the Thomas Edison company, Edison company, electric company, and one was the Westinghouse company. So he was working with Westinghouse company. He disagreed with Thomas Edison here that powering the DC with the world with the DC was not practical, because it couldn't be done. So how they did settle up, or how they came to an agreement, or how they finally finalized the issue. In 1904 was the settlement of the issue became to a resolve. Westinghouse Company's bid for lighting a lamp was less than 25 cents, which is cheaper 5 times or at least 4 times cheaper than Edison's company. So, and that's how they got this the contract, and the whole world light up with the AC power right there. So that was the review of the AC and DC there. So who won, who lost? There is no winner and there is no loser, because we still use both of them. But that's how we got AC and a whole the world transmission um, lines, like the big transformers, big transmission lines are the AC. But in the DC will be our or more control voltage that we use it in our industries, or in a circuit board. Anything that you have a circuitry, that will be a DC, like your phone, uh, your batteries, they're DC, because don't have to be, they're only going one direction. Okay, so let's move on to our next topic, which is alternating current waveforms, or AC waveforms. Okay, so AC waveforms, it looks like in this picture, in the video, like you see like in the background, the graphic, it's pulsating, it's going up and down. It sounds like a sinusoidal, but it is some kind of waveforms there. Okay, so let's go to the next topic, will be a square wave. Square wave. The square waves are the waves when it goes, so what are they? You see the picture here? So it's going all the way positive, it stays positive, then it goes down to 0, then it goes to negative, stays negative, then go back to 0, go to positive, stays positive, go back to 0, and they will repeat until indefinitely, until you tell, like, how long the length of this wave is. So that's how we define this thing. The waveform, when it goes to positive and stay there for a while, and then return to negative and stay there for a while and keep going, and this change in polarity, we call that a square wave, because you see like it's perfectly square. Square wave can be generated using an electric device called an oscillator. So oscillator will generate these square waves. So what is an oscillator? I'll put it there, a device that can produce periodic electric signal, or a device that is used to change DC to AC voltage. That is an oscillator that will just change it. They will create these waves for you. But there is another device we will talk about later that do convert DC to AC, and there is another device that convert AC to DC. Hang tight, guys, we will talk about them too. So square wave can be generated using an electric device called an oscillator, and this is your definition of oscillator. Here, a simple 2 bipolar transistor type is sometimes used to convert 12-volt DC. We will talk about this term transistor and maybe in the next few coming lectures. I can't say when, but yeah, we will be talking about transistors too. That sometimes convert 12-volt DC to 120-volt AC to power electric hand tool. So that transistor job is to convert 12-volt DC to 120-volt AC, because we are required to use that electric hand tool that will be 120, and that should never be used to power up your TV, 120-volt TV, like, or microwave, because this battery life, or That will be just for a quick use because TV take a lot of more power or stands more, so that will maybe damage your battery on the hand tool battery, or that might damage your TV. So that should be a precaution taken not to using your oscillator in which you convert the DC to AC and then you power up the TV. That should not be allowed. So please guys, don't do that. That will be only for your hand tools like electric guns and anything that you have in a hand tool, like let's say a hand electric gun or tool, a screwdriver, electric screwdrivers, and these things that should be okay. Okay, moving on to now the second wave is the triangle waves. A triangle wave is a linear wave, and a linear wave is a which voltage rises with respect to time. It's called a linear wave. Okay, so in respect to time, every time this is my time axis and this is my voltage axis. While my time is at 1 second or 1 millisecond, this will be 20 volts. If it is 2 seconds, it will be 40 volts. If it is 3 seconds, for instance, or 2.5, it will be 80 volts. So it is changing with respect to time. The time goes up, the voltage goes up, and that will be the peak voltage right there. But to keep going, if the time is going, it will drop its voltage coming down right here. So that's why it's called like it's a linear, because it changes due to another aspect, which is time. The time changes, the voltage changes. That's what it's called, a linear wave, or a wave in which voltage increases and decreases with respect to time. That should be shown in this picture perfectly right, because the time goes high, the voltage goes high, then the time goes low, the time keep going high, the voltage keep changing. So it's changing with respect to time. Okay, now there's a other, and the very famous one is the sine wave. Sine wave is the most common of alternating current waveforms because yes, our most AC is our sinusoidal wave, so that's why it's most common. It is produced by a rotating machine like your motor, big motors, small motors, any AC motor will produce these sinusoidal or sine waves. This contains 360 degree. Sine wave contains 360 degree. So what is the peak is at 90 degrees. So this is your 90 degree right here. Going from 0 to 90 is your peak degree right there. Coming back here is back to your 0 will become 108. Sorry, so peak is your 90 degree right there. Coming back to 0 voltage, there's 0 right there because this is your amplitude, your voltage there. 0 voltage will be your 180 degree. Then going back to negative peak value, this one right there, will be, again, you add up 180 to 90 will be 270 degree, but in a negative direction. You're going back to this place, going back to 0, and that will become your add up to 70 and 90. That's your 0 volts again, will be 360 degree. So it's from here, start 90 degrees right there, 180 degrees right here, 270 degrees right here, but in negative direction, and 360 degrees right here at 0 volt again. So your only peaks are at 90 degree and at negative 270 degree. So, and this, if you see that one right here, our cycle start from here. There is a one peak, there is the second peak, and the cycle, your cycle finishes right here back. Because the way you started, the way you finish it back, that's your one cycle. So starting from this point to this point is your one cycle. Your peak to peak value is, this is the one peak, this is the other peak. That's your peak value. Peak to peak value right there. This value to that is your peak to peak. This is your only peak. Peak is from 0 to your positive or negative maximum value is your peak value. From negative maximum to positive maximum value is your peak to peak value, such as this one. And everything we call these This is your time axis. Amplitude can be voltage there. So we'll go into deep with that. So frequency is the number of complete cycle that happens in 1 second, which is called frequency. And hertz is the symbol or unit of a frequency. So most of the European countries, including Russia, use 50 hertz, that is 50 complete cycle per second, and USA and Canada uses 60 hertz. That is 60 complete cycle per 1 second, and that's your frequency right there. Okay, it's now the sine wave. It's called sine wave because voltage at any point along the waveform is equal to peak or max value times the sine of the angle of the rotation. So that's why we call it sine wave, because the voltage at any point along the waveform is equal to its peak or maximum value times the sine of the angle of rotation. So just to put it in this way, so any point is equal to the peak voltage times the angle of rotation. That's what it says. That's why we call it sine. That's why we call it sine, because it requires a degree of rotation there to find the instantaneous or voltage at any point. So this is what is a V instantaneous? Is a voltage at any point. Max V is V max is your maximum or peak voltage, and that's your rotation angle. Okay, so in this we will cover these examples here. The example number 1 is, say the sine wave has a maximum voltage of 480 volts. What will be the voltage after 165 degree of rotation? Example number 2 is a sine wave has an instantaneous voltage of 250 volt. After 55 degree of rotation, what is the peak voltage? And example number 3 is a sine wave has a maximum voltage of 250 volts. At what angle of rotation will the voltage reach 85 volts? Now example number 4 will be a sine wave has reached maximum voltage of 480 volts. What will be the angle of rotation when the voltage reaches 220 volts? We will solve these examples in a scratch paper. We'll go to each example. Please stay with us. This will, after these examples, this lecture will conclude. Okay, so the solution to the example number 1, we'll go through all from 1 to 4 for this these example sections. So example number 1 is saying a sine wave has a maximum voltage of 480. So V max is equal to 480 volts. And what will be the voltage after 165 degree of rotation? So sine of rotation is 165 degree, and we want to find the instantaneous voltage. Okay, so we were given this formula. V instant voltage at any point is equal to peak voltage or maximum voltage time sine of rotation angle. So V instantaneous is equal to V peak. We got a peak voltage of 480 volts, and then time sine of 165 degree. Okay, so the answer here will be, okay, so 480 time sine of 165 is 0.9977. 0.997, make it 78. So V instantaneous is equal to multiply 480 time 0.9978,
we get 478.9 0.94 volt. So voltage after 165 degrees of rotation is equal to 478.94 volt. So it just lost 0.106 volt there. Okay, moving on to example number 2. Example number 2. In example number 2 says like a sine wave has an instantaneous voltage of 250. So V instantaneous is 250 volts. After 55 degree of rotation, what is the peak voltage? So sine of rotation is equal to, not theta, sorry, 55 degree. So it asking us to find the maximum voltage. Okay. Our formula was V instantaneous is equal to V max time sine of angle of rotation. We want to find this guy. So we will divide both sides by sine of rotation. So V max will be equal to instantaneous voltage over degree of rotation. And we will get okay, so it was 250 volt, and divided by sine of 55 degree. Alrighty, so let's find out sine of 55. To find sine of 55 on a scientific calculator, you hit the sine button, then you enter the value, which is the 55, then you close that parentheses, and it will give you the value of that. Sine of 55 is negative 0.9997. Okay, now 250 divided by negative 0.9997 will give us negative 250.07 volts. So that's our max voltage here. That will be in negative direction. It should face the, sorry, that's a eraser. I don't know why that gets there. So this is our instantaneous. Our max voltage here is 250.07, but in negative direction. So it will be like going that. Let's say sine, as you can say, sine wave. So somewhere here will be our negative direction in this line below the zero, which is negative direction, negative area, and this is plus area. Okay, so that will be V max. Voltage at peak will be to negative 250.07 volt. Alright, moving on to the next example, number 3. Example number 3 is a sine wave has a maximum voltage of 250 volt. So V max is 250 volts. At what angle of rotation will the voltage reach 85? Okay, so V instantaneous is 85 volts. So the sine of rotation is not known. So we will use our formula again. V instantaneous is equal to maximum voltage times rotation of the angle. So we want to find the sine rotation. So we gotta multiply. We'll divide both sides by the maximum voltage. So this will cancel out. Sine of rotation of the angle is equal to V instantaneous, voltage instantaneous, and voltage sub max, or maximum voltage. So the instantaneous voltage is 85 degree, and I'm sorry, 85 volts, and the maximum voltage is 250 volts. Both will cancel out. Sine of rotation will be 85 divided by 250. 85 divided by 250 will give us 0.34. Now to find this angle, we have to take inverse sine of this number. That means in your calculator, if you're using FX11ES plus, that's what I'm using currently, is a scientific calculator. So you okay, so before we using the calculator, we have to see what are we dealing with them. Since we are asked to find the degree, our calculator should be in a degree mode, not in a radian mode. Otherwise, I'll give you the wrong answer. So what you'll have to do in your calculator will be sine inverse sine of 0.34. Punch that number in your calculator. So it will be, you hit that shift button, then you hit the sine button, then enter the data and hit equal to. It'll give you the rotation angle. It will be 19.87 degree. So this is your angle, and this is your sine of a number. So this is a sine of an angle, and this is a angle actually. This is the value of this number. So sine of 19.87 will give you this value. So to find a value or angle of a sine, you have to take the inverse of the value of this sine. It'll give you the angle of that rotation. We will do one more example. It'll be clear. So our sine is, the rotation angle is angle is 19.87 degree. So there you go. All right, number 4, example number 4 will be a similar example. It says a sine wave has reached a maximum voltage of 480. So E or V max is equal to 480 volts. And the instantaneous voltage is, what will be the angle when the voltage reaches to 120? So V instantaneous is equal to 120 volts. So what will be the angle? So the angle is asked. We don't know that. So we will still use the same formula. Sine of rotation angle is equal to V instantaneous divided by V max. So V instantaneous is given 120 volts, and V max is 480 volts. Volt will cancel out. We can cancel out these zeros too. So it'll be 12 divided by 48. It'll give me 1/4. It'll be 0.25. Now 0.25 is our sine of that. Sine of rotation is 0.25 is the value of this angle. But we have to find that angle. To find that angle, we gotta do inverse. Inverse of a sine. So what we will have to do, inverse sine of 0.25. And your calculator, press shift, then sine, and then enter that data and close the parentheses. It will give you the angle. But make sure before you do that, check your calculator should be in degrees, because we are dealing with the degrees right now, not radians. It'll be 14.477 degrees. So your angle of rotation is 14.477. Okay, I hope this makes sense. These example require some practice, and that's what it is like. If a motor is turning around, AC motor, if it's going either direction, if you know the angle and if you know the maximum voltage, you can find voltage at any point at any angle. This will conclude 4 examples, from 1 through 4 on the first session of the lecture. And the next lecture we will be talking about sine wave values. Sine wave values, W and V sound. I struggle a lot. I'm sorry for that. So until then, please go and practice these examples and try to make more examples and practice on them too, or search more examples and practice on them. This will be helpful if you're going to be a skilled trade or electrical engineers or even mechanical engineer, any mechanical electrical engineering side. This will help you a lot. It's very practical. These are practical examples, so don't hesitate to ask any questions. We will continue on part 2 of the lecture in the next video, so please don't forget to hit that subscribe button.